Buonasera. Welcome to Go for the Long Game. For those of you unfamiliar with the term, playing the long game refers to active participation in achieving goals, which may take some time. So it's one who follows, or a group who follow, a long-term strategy. That is said to play the long game. I want you to imagine a mental model for the long game. What would you picture? Active participation in achieving goals, which takes some time. To me, this sounds like a journey, a metaphorical road trip, if you will. And here we have one with start. But before we begin this journey, I'd like to undertake some preparations before moving forward. Before we want to start any new venture, it's helpful to understand a bit more about where and why Go was made. Without exception, all ideas come from previous ideas. They are the combination and the maturation of old, and in Go's case, they're born from the very same people. And even though you'll see some of this growth of ideas in programming languages, you'll also find an anomaly within Go. I give you this magnificent 80s video game still art. I will give bonus points if you can find me afterwards to tell me which game, because this is my very first. But I give it to you because a criticism I often hear about Go is that it is a language stuck in the 1980s. And so going back in time, when we reflect or retrospect, it means going back in time. And we do this often to prevent mistakes from repeating in the future. And that Go has taken all the last 3+ decades of language design evolution and seems to just ignore it fascinated me. IBM 3270 font is hard to read. I also had to give homage to the 70s. How did they even back then? And there was no syntax highlighting or color coding. I can't even. But anyway, these are the complaints which will be mentioned in a new light in our future trip. So too simple, lack of syntactic sugar, no generics, bad dependency management, stuck in the 70s or 80s, bad error handling, no unused imports, too opinionated, too verbose, no ternary operator, no macros or templates. And I gave a talk about exactly this called The Why of Go. And I even said, why Go, why? But I guess I give you the ability to travel back in time in that talk. And to see, if you wish, to go look at the full talk. It was the product of my quest to find out about the why of Go. And I won't repeat all of it because this is a new talk, but I did want you to see those criticisms listed at least. And think about traveling with them into the long game, because they'll come up in our travels at a later stop. Foreshadowing intensifies. So we're back in the present day. Let's get coding. The first stop in our journey in the long game is your skills acquisition. And so you have to ask, if this is a Go conference, what makes for good Go code for longevity? And what makes for code that will stand the test of time? And there's a lot that I can say about why Go is well suited to longevity as far as structure and syntax, but I only have 38 more minutes for this talk. And I also need to take us much further than this stop. And also a lot has been said and even been deep dived on what this is and what it looks like. And so what do programmers do when we want to go far, but we also want to deep dive and we want to do it quickly? We import. So I want you to think of the long game as an accrual of learning, knowledge, skills, experience, and finally wisdom. And here I have taken the concept of imports, because imports to me really exemplify how we can share knowledge and experience with each other. Please note for my coding nerds that this is of course an idea and these are not actual import paths. Do not take my sudo import code, whatever. But some of these are URLs to blog posts. Some are conference talks. Others are part of GoLang documentation. And this slide deck will be available with actual links after the talk. But anyway, all of these are great resources for structuring your Go packages. And so I kind of cheat. We're not going to talk about them here because I want to get to other things, but I leave them as gifts for you to consume at a later time. And they're great resources for structuring your Go packages and applications or organizing Go code. Tips and tricks for clean APIs, maintaining clear package boundaries, import paths. So there are many benefits over time when you take the time to structure your code and organize it well. And so most of these are part of Go's opinionated style, but even more, there are conventions that are developed over time by the ecosystem and the community. And all of these talks will save you much more time than having to learn things by hitting your head against a wall, though that's effective, but it's also the unnecessarily long way. Or the tangled way. Ah, yes, the tangled road sign. We've seen that, right? Well, we've seen it when it comes to mental, metaphorical road trips. Come on, give me the benefit of the doubt. All right, so we've done a quick drive-by, and we've picked up some of this resources for code, and for good, long-lived code. What's next? If we look at our long game as a metaphysical, ooh, maybe? Too trippy? No, as a metaphorical journey, we observe that the travel that I've mentioned before is temporal, right? It takes time. And so the rest of my talk will focus on things that are both integrated and looped into the code and move beyond it into software engineering. And so this long game journey comes in five more parts. Process, change, team, grow, care. So our next stop, process. I want to mind bend our mental metaphorical journeys here with some additional conceptual models. So please bear with me. The long game of learning Go, and so, oh, yeah. The long game of learning Go in software engineering, using this simple roadmap analogy, it kind of starts to have limits. And so we need to add some additional nuance, which should help, but it shouldn't complicate things. So if you will. The road here, it's literally a dot connector. And it moves in a forward direction. And there are two ways I want you to conceptualize this long game in your head. The first is integrative. Integrative means to put together parts or elements and combine them into a whole. So you take one thing and you add it to the other, and you keep adding and you keep adding without getting rid of the previous one. And in this integrative conceptual model, each of these points in the journey takes in wisdom and knowledge accrued from the previous stop in time and adds it without omitting anything. And it's much how we think about the total net knowledge of wisdom we acquire through learning and experience and practice and repetition. And there's a progression that is an overall improvement over time. In the second conceptual model, instead of presenting these places like a sequence of steps that are linear and unidirectional, we are going to change this whole thing into a fast, continuous feedback loop. And I'd like to call this model the betterment loop, because it literally feeds back to the code and, as the name suggests, continuously loops over these steps. And the important things here to remember are that is, one, it's continuous. Two, the loop feeds back into itself. And above all, it is meant for iterative improvement. And so when we put the two together, integrative and betterment loop, you can think of it as a betterment loop that happens continuously along the longer linear journey of your project or your career or your company, whatever long game you're going to specify. And you do all of these things in sequence, but in very small chunks, and you iterate and you repeat. And we can see this idea of smaller chunks of cyclical movement within larger movements in nature. Think of the orbit of the moon around the sun and the earth. the orbit and the move around the sun, the Earth, and the Earth around the sun, and so on and so on. And you'll start to notice when I put it this way, in terms of putting it in your head, that the long game strategy gets very messy, chaotic, unwieldy. And you're right. But this is good for a mental model, because our brains are a complex network of interconnected betterment loops, all feeding back continuously into each other. And it is the near simultaneous feedback that makes our brains far superior to present-day computational powers. And dense networks are useful, even the Cable Salad Hall of Fame. But the long game strategy also looks a bit like this widely shared diagram about the path to success. Who's seen it? What it looks like and what it really is. And now you know what's really in those loop-de-loops. Anyway, putting aside messy, mental, metaphorical journeys, I'd like to just abstract that away now, and let's return on to our longer journey. And I'd like to go from this meta process that I just talked about to a more pragmatic process. So let's return and be more specific to Go. So namely, the development process. So there are 6 parts that are kind of standardized or agreed upon in a development process, right? Scaffold, develop, test, integrate, and optimize. Or optimize and deploy, with optimize being make it correct before you optimize it, right? So let's talk about a couple of things that sort of where Go helps in that development process. One, it's statically typed. So types provide a contract between various pieces of code running together, right? And without this automatic type checking during build, if we wanted to adhere to strict coverage rules, we would have to implement these contract tests ourselves. And this is the case with environments like Node.js and JavaScript. So writing a comprehensive contract tests manually, it's a lot of extra work that we prefer to avoid. 2, Go is simple and dogmatic. So it's known for being stripped of the many traditional language features, like in the classic object-oriented inheritance. Complexity is the worst enemy of long-lived code. So problems tend to creep up in the seams. And while the common case is easy to test, it's the strange edge cases that you haven't thought of that are going to eventually get you. And so dogma is also helpful in this case. There's only one way, often one way, to do, There's often only one way to do something in Go, unless you're Ellie, and then she will try to prove you otherwise. But critics claim that this inhibits creativity. But when there's only one way to do something, it's more difficult to get this one thing wrong. And so it helps others onboard and learn and grow the ecosystem, and more on that later. Concise, yet expressive. Readable code is easier to review and audit. And if the code is too verbose, then its core purpose may be drowned out by the noise of the boilerplate. And if the code is too terse or concise, it becomes hard to follow and understand. And Go strikes a nice balance between the two. There's not a lot of language boilerplate like you might find in C++ or Java, but the language is still very explicit and verbose in areas like we know as error handling. And it makes it easy to verify that you've checked every possible route. Speaking of error handling, Go has very clear paths of error and recovery. Dealing gracefully with errors in runtime is foundational for good, long-lived code. So Go has a strict convention of how errors are returned and propagated, and environments like Node.js, and in my previous talk, The White About Go, I really knocked on Node.js, but I'll just briefly state here, there's multiple flavors of control flow in Node.js, like callbacks and promises and async, and they're all just mixed together. And it results in this leakage and unhandled promise rejections. And recovering from these is almost impossible. And the standard library, so deps and dev velocity. Go has an efficient, small even, not bloated, standard library. Dependencies add risk, especially when coming from sources that aren't necessarily well maintained. And when shipping your service, you ship all of your dependencies with it, and you're responsible for their malfunctions as well. And environments overflowing with fragmented dependencies, like Node.js, are harder to keep for the long run. And this is also risky from a security standpoint. As you are as vulnerable as your weakest dependency, Go's extended standard library is well maintained, and it reduces reliance on external dependencies. Go also has a bit of a story with regards to the dependent management story. And I'll get to this in a bit. My very last point to make here, Go is optimized for fast compilation, which feeds into iterative development. It makes it cheap to test out new stuff because you don't have to wait a long time for stuff to compile. And very clear module boundaries to keep these import dependencies between packages linear, thus keeping compile times down. This sign right here, who knows what it is? Who's seen it? Anyone? Yeah, can you say? Yeah. So shout out to my Deutsch friends. It's the sign for no speed limit on the Autobahn. So I want that to be the visual that you see. So like fast iterative development, cheap to test new stuff. You don't have to put on the brakes. Anyway, remember that 80s game and everything that I said about the criticisms of Go? Everything that is used as a complaint in the language is actually a strength in many cases for the long game. 80s rule. Sorry, mental, metaphorical journeys do take nostalgic rest stops. All right, we continue on to change. But first, a detour. Before we proceed in talking about change, we have something to consider. Two things, actually. One is programming. The other is software engineering. In my Why of Go talk, when understanding Go's past and the direction it wanted to take for the future, I found a gem of a talk by Titus Wintners, who is the C++ tech lead and he maintains the C++ libraries at Google. And it was a CPPCon keynote. And I don't write C++, but the first 12 minutes or so of this talk were brilliant. And so I used that portion verbatim to talk about the original zeitgeist that informs why Go makes some of the decisions it does. And Russ Cox, the tech lead for the Go programming language, would also use the very same portion of that talk earlier this year in April, when talking about modules, Go modules, and dependency management. And I urge you to go and see, you don't have to see my talk, but you can certainly see, there's my pseudocode import alias, Titus Remix Rust, and of course the original. But Titus asked and answered the question, what is the difference between programming and software engineering? Why do we have two words for these concepts? A programming task is, hey, I got my thing to work. And that's hard. Sometimes the right answer to a problem is, I'm going to write a program and solve this and be done with it. Software engineering is programming integrated over time, meaning change. Engineering is what happens when things need to live longer and the influence of time starts creeping in. Library versions are updated. The OS is deprecated. Languages are revised. The requirements have changed. You have to write new features. Other developers are working on the code base, changing services to have different options, rollouts, updating new servers, updating front ends, complex networks of servers, moving to a new team. Time happens. Things change. And how you handle that and how you keep your program working is engineering. And it may bleed into the programming itself, or it may be layered on top. And all of this complexity is a fundamentally different flavor than I got it working, than programming. And sometimes it's not needed. We don't need to plan for change. But when you aren't certain and when you have to be prepared for change, this is software engineering, the impact of time and change on a system. So the point is, Something that makes sense on the face of it turns out to be a horrible idea when you start to think about change over time. So there are many things that we do that make perfect sense in a limited domain, in a programming domain, but do not make sense when we're thinking about it as engineering and thinking about change over time. So indeed, everything that we think about when we think of software engineering is about resilience to change over time. Version control, go back in time, coordinate with your colleagues in time. CI, continuous integration, making sure recent changes haven't broken the system. Unit tests, making sure the feature you won't be broken in the future. Refactoring, update from the previous time to the present time, or the mode. Design patterns, ability to plan for future changes without knowing what those changes will be. Dependency management, libraries or packages that we depend on may change. So Go's holistic approach absolutely understands this about software engineering, in my opinion. Specifically, the focus on readability. That's going to be hard to see. It's an import from a Go release party. I think it was 1.8 for the Tokyo Go meetup group. And it's idiomatic Go readability, and it's got some great resources there, and why readability is great with Go and how that helps with your software engineering. But if you write code with polymorphism and meta classes, imagine needing to debug that code, maintain that code, having to ramp up that to the growing code base, which at large companies and projects, think Kubernetes, think HashiCorp, think anything else that's a huge Go project, it's going to be growing by thousands, even millions of lines across hundreds of contributors every few months. And sustaining engineering through readability is a must in the long game. The next thing I want to talk about is turnover and company switching for engineers. This averages about 18 to 24 months, at least volatile Silicon Valley. I don't know how it's here in Europe, but 2 years on average. And so the only guarantee is that people will leave. And this is the reality of working in software engineering in 2018. And this is the context that matters beyond the programming language itself. And so therefore, boring solutions are encouraged. Why? Because they're often the least complex, they're the easiest to maintain, the most efficient, and people who come and go of varying abilities and skill sets can figure it out, can ramp up into that, and can get into it and contribute. So we talked about change and turnover certainly affects this next point in our long game. Let's talk about team. The thing that I want to talk about with teams and Go after turnover, and it's mentioned, you're going to have new team members coming in and out, is this readability, but with this context. Software companies have to hire people. More realistically, they should hire inexperienced people, right? And have you ever noticed that 95% of job descriptions hire at only like 2 levels, like senior engineer and super senior engineer? I mean, I'm going to stop here because I can't text and drive, but I'm going to just send off this eye roll emoji off to Twitter, because stop hiring only senior engineers. Grow your junior talent, for crying out loud. There, retweet that. It's my handle. All right, returning a team. Regarding different levels of experience and growing Go for talent, let's talk about trade-offs. I want to first start about that before I get into it. Go may not be the most newcomer-friendly language compared to some others like Ruby. And I think that there's something that needs to be addressed in this payoff. It's not black and white, it's a spectrum. Learning curves differ, and payoffs differ too. Go is sort of between a spectrum of C and Ruby. Sorry, of C, Go, and Ruby, right? And it's in between. And Ruby trades off intuitive, accessible APIs. Go makes the trade-off for CPU efficiency. And there's a cost on both sides, right? And if you look at this spectrum, C, Go, Ruby, I think Go is a good between. The hardcore systems people might sneer at Gophers for having a garbage collector, but it makes the code a gazillion times more maintainable, right? So anyway, those are the trade-offs that I just wanted to get out of the way. And Go is simple in the long game, but the payoff is upfront in learning the type system. So now that we've kind of talked about that, let's talk about Go and what it does for helping teams. Simplicity and readability. Go is read far more times, or code in general, right? It's going to be read way more than it's written, right? Again and again and again. And I've mentioned Go's simple syntax, and it brings out a lot of opinions, but I've started to notice, not from those who have been in coding for like a very, very, very long time, except for Ellie, but that's different. Not those like 5 years in trying to prove their cleverness. The people who designed it and the people who understand its power strive very hard to continue to simplify it. And I think of this Brian Kernighan quote. Oh, I didn't add it. I love this quote. Brian Kernighan helped write the C book, and he was at Bell Labs, and he worked with Dennis Ritchie. So for those of you who don't know him, that's a very smart guy. And he says, debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. So having a simpler, often readable, repeatable syntax greatly helps with team rapport, and it helps level up inexperienced developers. In this vein of inclusivity and diversity and helping to hire from more underrepresented groups, I think Go's, once you get past the trade-offs, employees can be at different skill sets and have different specialties, and no one knows the same things, but the things that got left out of the language are going to encourage people to sort of kind of rein things in to help collaborate. And so it's going to help encourage people, everyone, comfortable enough to admitting when they don't understand something or when they don't have an answer. And I just spoke with some very smart people yesterday that are very good polyglots that say, you know, I've been coding since Go's inception 10 years ago. And each year I say, I think I know Go now. And then the next year they say, no, now I think it. And there's a really good community person named Dave Cheney. He's from Australia. And he kind of surprises us every couple months with a Go quiz or a Go gotcha. And I think that kind of sort of talks about or helps us sort of say, well, here's this simple language, but it still has a complexity and a nuance that takes a long time to master. And that's really good for helping and honoring diverse skill levels. And when you're working, the answer isn't going to be about something as silly like about style or formatting, right? So speaking of style or formatting, I've already mentioned how having opinionated or only one way to do things can stop silly code style debates before they even start, right? Like, thank you, Go font. Thank you, right? I don't want Rubocop in my life anymore. Anyway, but also it helps with having to learn widely different dialects that the more expressive languages allow. And it's in this simplicity that we can level up and bring more people to our industry from underrepresented groups. The last thing in its opinionatedness for our teams is this: we can also ironically have more inclusion because we are doing more sort of opinionated standardization. In the context of order, sustainability, dependability, it's a benefit. And it's imperative that in some aspects of software engineering and in code, simplicity needs to be enforced. And an example is road signs and road rules. So the system to imposing limits affords us all the ability to use it efficiently and effectively, the roads and automobiles and whatnot. And imposing limits like this makes things possible. And it evolves to the point where anything that needs to be changed, it can be changed. And this is sustainability for teams and for your projects and for the long game. And if you feel like this is very top-down, you're right. But Go is first and foremost a language meant for this context, right? Rob Pike, one of the founders of Go, said that Go is meant to be used in a big digital highway where traffic laws need to be obeyed, and there's tons of people that need to kind of follow these rules. All right, So we're arriving at our last 2 points in the journey, and we won't stay long at either. Growth. This can mean a lot of things. I kind of didn't know where to go with this, so I'm going to sort of get you to think about how you want to be explicit about this growth. It could be growth of you as an individual. It could be the growth of your team. It could be growth of others you're helping. It could be the growth of your open source project. It could be growth of the Go community and the ecosystem and the tooling. So basically at all levels. When I think of growth, at least one point I haven't yet talked about is project governance. And this gets away from Go, but it's still important because it's kind of an industry standard of how we ship software today. So we're talking about at least open source, READMEs, documentation, contribution guidelines, code of conduct. They're industry standards with all programming language. And Go, in the previous places that we visited, so things I talked about like readability, simplicity, standardization, that helps with collaboration. And collaboration is what is needed to grow. And the best growth kind of takes this form of iterative betterment loops and improvements. And it also takes the form of trying to stave off as much as possible complexity, which, again, I've kind of banged on quite a bit about how the language does that. And so it does kind of lead me back to why Go has such a small language footprint and why Go moves so slowly in what they add to the language. And who knows when Go 2 is going to come out. I mean, really, people think it's going to be next year. I'm taking my bets for longer than that. But I'm fascinated by it, right? And if you ask any engineer who's been one in software writing code for more than, I mean, really, the super duper long game, like more than 15 years. Growth is knowing when to not add something, right? To reduce where needed and only where needed. And I think that's what I want to learn as I kind of like want to grow, and I want to leave that as a takeaway for you when you think about growth. Okay. Care. We've reached our last point in the journey. Care. When I talk about care, sure, I talk about project and code and company stewardship, but I really want to talk about software maintenance. So what happens to your code after you deploy it? I think of code as having a life cycle. The software has been creative and has been birthed, and now it needs to live a life, and maybe a long life, right? And a paradigm shift in the way that we think about operations was introduced to me when I first started my new role by my colleague Igor Develer. Operations is what happens as you care for that software after it's born, right? And in DevOps, you shape and you mold it and you iterate upon it as it grows. You care for it, you improve it, and you make it mature software through care. Now again, this has less to do with Go, at least at the very beginnings of a project, a greenfield project at the start, but everything to do as you tune and mature your software, whether it's going to be Go or another language, over time with the practice of software engineering. So operations, right now, I want to change the way that we think about that. I do not want operations to be thought of in terms of firefighting. I want it to be thought of in terms of caring, healing, stabilizing, nurturing. And this could mean your new greenfield project with its new users, or maintaining your legacy code. And I put elderly care there because everyone kind of moans and complains about legacy code, but it's got to be done. And the vast majority of production code is indeed legacy code. So I want this industry to have less hero culture, to be forgiving of the software that we build, because it will have flaws, just as we humans have flaws. It's going to fail. Failure is the standard. And it is our jobs to expect that failure and to make it better, to care for it, and to do so again and again and again. So I hope you've enjoyed journeying with me, and I hope that you have some good resources and takeaways as you begin your own long game. And as I leave with you, what do you think comes next? I want you to enjoy the journey, not the destination. And don't forget to be kind on the way. Thank you.